So basically, that's what I'm going to talk about. The causes of these radiation hazards in outer space. And basically, since 1972, no one walked on the moon again, for obvious reasons. It's not safe. Why didn't we send people on Mars? It's not safe. Why are the moon and Mars so different than the Earth?
Because they don't have magnetic.
Okay, very good. Your answer is correct and your answer is correct. So, keywords are atmosphere, magnetic field. And I explain exactly how it works. So, how does the sunlight connection work? This is a cartoon that illustrates the sunlight connection. You have the sun, you have the solar wind traveling through space, it arrives at the Earth, gets the first shield, which is the magnetic field. We have some bar magnet sitting somewhere in the liquid chloride inside here that generates this magnetic field, and it basically deflects the solar wind particles away. Why? Because the solar wind particles are, what are they? They're ions. Electrons, protons, and what else?
The
alpha particles. The alpha particles. They have electric charge. When they feel magnetic field, can they go through the magnetic field? What do you know about magnetic field?
They're charged.
They have a positive
I
charge.
know that, Ilia.
Huh?
That might be 12th grade physics.
12th grade physics?
They have
Yeah.
positive.
Okay. Then we'll skip 12th grade in 1 minute. Neutral particles can go through the magnetic field without any problem. Charged particles, they cannot. Once they feel the magnetic field, they can't get through. They can spiral along the magnetic field, but they cannot go through. So magnetic field shields, it can separate neutral particles from charged particles. Magnetic field does not allow charged particles to get through across the magnetic field. Okay? What is magnetic field? You know what magnetic field is. Now this is a very important piece of information that you need to remember about interaction of charged particles with magnetic field. But now, once a charged particle lands on a magnetic field line, what does it do? It spirals, it follows the magnetic field line. Okay? If I have a little ball here that slides along this wire, that's what a charged particle is going to do. Approximately. In reality, what it does is it spirals along the magnetic field. And each time it encounters strong magnetic field, it reverses direction, so it can bounce back and forth along the magnetic field line constantly over an extended period of time, forever. Okay. All right. That's it. 12th grade is over. So this is what happens. Charged particles arrive here. They encounter the magnetic field. It's this shape, and the particles are deflected away. Right? But sometimes, I'm going to play you a little more. All right, here it is. Here is the Earth, here is the magnetic field. This is the magnetic field coming from the sun. I forgot to tell you. Solar wind, magnetic field, the sun also has magnetic field. When the solar wind goes through space, it also carries the magnetic field with it. Okay? So when you have particles moving in one direction, because they're tied to move along the magnetic field, when these particles move in one direction, they drag the magnetic field line with it. Okay? Can they do that? Sure they can, because this is like a marriage. Charged particles and magnetic field are married. Once the particles get in here, that's it. So when the particles are moving in one direction, they drag the magnetic field with it. So that's what the solar wind does. The solar wind carries the magnetic field of the sun throughout the solar system. And this is the solar magnetic field. When the magnetic field, we call it interplanetary magnetic field. When this magnetic field is in the opposite direction of the Earth's magnetic field, something mysterious happens. You see how the two field lines, it's like taking two field lines, cutting them, pasting them in a different way so that they look. Do you have a rubber band? So this is a hands-on experiment. This process is called magnetic recognition. This is how you create different set of magnetic field lines. So, oh, great. Okay. This is a good thing about lab. You can do all kinds of experiments. So you can imagine this is a magnetic loop. This is an entire magnetic field line. Okay. So magnetic field has a direction. Imagine that it goes from here, goes up and down, and completes a complete circle. Now, if I push these field lines right here, what's going to happen? We have one polarity of the magnetic field here, opposite polarity there.
They're gonna repel.
Actually, they're going
Oh,
to
yeah, I'm sorry.
attract. So I take now scissors, I cut right here, and then I paste the edges. And as a result, what do I get? I get two new loops. I get two new loops after this cut and paste procedure. This process is called magnetic connection. It only happens when the magnetic field here and here has opposite signs. Okay? So this way, from one magnetic loop, I can make two magnetic loops. Okay? Same thing happens here. I have to freeze this. If you understand this, you're ready for college. Skip high school, you can go to college right away.